When we're doing a confidence interval for a single proportion, if the central limit theorem holds and our sample is big enough, we will be able to use what's called a critical value here, a z star from the normal distribution in computing our confidence interval. And so we're going to go through how you look up this critical value in StatKey based off the amount of confidence you want. The three that we're going to look at here are three that are not as common of confidence amounts that we typically use. The three most common ones are presented down here in the table. So these ones are often the z's that we'll be using, which can be obtained from StatKey, the same way you're going to see me do these other three. But so this is just an illustration of how you'd find this value for any amount of confidence that you want to use. We are not restricted to a 95% interval. So let's say we're asked to do a 92% confidence interval. The question is, what would this z star value be? So you go to StatKey now, and if the central limit theorem holds, we can use the normal. So the z is going to remind us we're using normal. If we click on normal, whenever we do our confidence interval, we're doing plus or minus, so we consider that two-tailed. It defaults to 95% in the middle, which you can see at the bottom has 1.96. We want to change this to 92% interval. So you can put whatever proportion you want here. We'll put 0.92. We hit OK, and if we look at the bottom, we can see our value is a plus or minus 1.751. And so what we're getting for our first z star is 1.751. And just to repeat that, where we're going to change the middle percentage to a couple other values. So at 85%, we would change this value here in the middle to 0.85. We get 1.44. And then I'll do the other one here too. We had 80%. And we get 1.282 at the bottom. So our other two for these ones were 1.440 and 1.282. And then if you repeated that for 90, 95, and 99, you would get these values down here, which are the very common ones we use. Notice that the 95% value of 1.96 is very close to that value of 2 that we were using earlier when we did the bootstrap intervals and did plus or minus 2 times the standard error.